In this series of videos, we're going to go over multiple design patterns and see how we can combine patterns in a single application. The examples in these slides are based on the book Head First Design Patterns by Eric Freeman and Elizabeth Robson. In a previous series of videos, I covered the design patterns from chapters 1 through 3 of this book. In this video, we're going to start with chapter 4, subtitled Baking with OO Goodness. In this chapter, we'll talk about a pattern that is used for creating objects. The typical way you create objects in Java is with the keyword new followed by a constructor. Constructors come from concrete classes, so when you see the keyword new, the constructor that follows it comes from a concrete class. Let's look at a method from a pizza shop application. The method's name is orderPizza. It takes an argument of type string that corresponds to the kind of pizza you want to order. Notice that there's a local variable pizza here with type pizza with a capital P. Pizza is an abstract class. You can guess this by looking at the if statement and seeing that the pizza variable will take on one of 3 concrete pizza classes: cheese pizza, Greek pizza, or pepperoni pizza, depending on what string was passed in. From that point on, the pizza objects are treated the same. The pizza is prepared, baked, cut, and boxed. And then the pizza is returned. Based on the first design principle introduced in this book that tells us to encapsulate what varies, we want to identify the portions of the code that vary. In this code, that would be the type of pizza that's created. So we'd like to remove and encapsulate that portion of the code. One way to do that is by creating a factory object. Factory objects are used anytime you want to separate the creation of an object from its use. Here, we have the class SimplePizzaFactory that contains a method createPizza. This method simply encapsulates the pizza creating code from the last slide. It takes a string and returns the appropriate pizza object. The class on the right is a pizza store class. It has a SimplePizzaFactory as a field, and the value of that field is obtained from the constructor. Now that the SimplePizzaFactory is in place, the orderPizza method is significantly simplified. The pizza object is simply obtained by calling factory.createPizza and passing in the type as the argument. Here's what the class diagram for this SimplePizzaFactory design looks like. The pizza store class has a SimplePizzaFactory object. The SimplePizzaFactory object creates a pizza. The abstract pizza class implements the methods prepare, bake, cut, and box, but the actual pizza will be one of 4 concrete types: cheese, pepperoni, veggie, or clam. An important part of this design is to notice that the pizza store object never refers to concrete pizzas. Only the SimplePizzaFactory refers to the concrete pizza classes. This means that if we add a new kind of pizza to our application, we don't have to modify any code in the pizza store class. The book Head First Design Patterns calls the simple factory pattern an idiom rather than a full-fledged design pattern. An idiom is usually thought of as something that is language-specific. It's usually a mini pattern that you're forced to use because your language does not provide a certain feature. Now, I can somewhat see how this simple factory might be considered an idiom in languages like Java, because some languages have more flexible methods for object creation. But to be perfectly honest, I think that there may be other patterns that Head First Design Patterns would call design patterns that are better candidates for the label idiom than the simple factory is. The singleton pattern and the iterator pattern are two that come to mind, and we'll discuss both of those patterns in a future video. Here's another design principle that relates to the factory pattern. Depend on abstractions. Do not depend on concrete classes. This is also known as the dependency inversion principle. And like the open-close principle, it's also one of Robert Martin's OO design principles. This principle is similar to the one that says program to abstractions, not to concretions. But the emphasis here is on dependencies and how the dependencies in a program, and hence the coupling, can be vastly reduced by using interfaces. Consider the pizza store class before we redesigned it using the simple factory pattern. The pizza store class depended on multiple kinds of pizza that were all concrete classes. Once we encapsulated the creations of pizza with a simple factory, the pizza store class only depended on the abstract pizza class. The concrete pizza types also depend on the abstract pizza class because they all extend it. So using interfaces and abstract classes can significantly reduce the dependencies in an application. Furthermore, the dependency inversion principle supports the open-closed principle. Adding a new pizza to the pizza store application involves extending the abstract pizza class, but it does not require modification of the pizza store class. It does require modification of the code in the pizza factory, but since that class encapsulates the creation of pizzas, pizza creation is its sole responsibility, we have minimized our risk of breaking other functionality in our pizza store application. Here's the simple factory pattern again. The pizza store has a simple factory object, and the simple factory object creates the different kinds of pizzas. The pizza store class still depends on the abstract pizza class because it holds a pizza variable that is instantiated with the simple pizza factory and used in the order pizza method. If there's more than one kind of factory that you might want to use for creating pizzas, you can use an abstract pizza factory in place of the simple pizza factory and implement it in different ways. Here we have an abstract pizza factory implemented by number 1, a New York pizza factory that creates New York style pizzas, and number 2, a Chicago pizza factory that creates Chicago style pizzas. This abstraction turns the simple factory pattern into an abstract factory pattern. However, a more common form of the abstract factory pattern creates families of related objects rather than one kind of object. Here, for example, instead of just creating pizza objects, the various factories create pizza, burger, and hot dog objects. Each type of object has its own abstract class and implementations that correspond to the objects that the different factories create. Notice that the signatures in the abstract factory must return the abstract types pizza, burger, and hot dog rather than a specific implementation. This makes sense because we may not know at compile time which snack factory implementation we're going to use. Here's the description of the abstract factory pattern. It provides a factory interface so that it can handle multiple factory implementations, and the methods in the concrete factories have return types that are abstract rather than concrete. And that's it for factory patterns. In the next video, we'll take a look at the singleton pattern.